Hi students. So now let us solve some of the important problems on differentiation. Already I have solved the important problems on continuity. Now I will go for the important problems of differentiation. Clear? So here the first problem is, if y equal to a into e to the power of mx plus b into e to the power of mx. See here, if y equal to a to the power of a into e to the power of mx plus b into e to the power of nx, you have to prove that d square y by dx square minus m plus n into dy by dx plus m n y equal to 0. Here you have to prove that d square y by dx square minus m plus n dy by dx plus m n y equal to 0. Clear students? So here the y function is given, you have to prove this. Clear? Very important. Clear? Very important problem of your exercises. Sometimes in your annual exam they have asked this question in your Karnataka board. Clear? So for that reason, if y equal to the given function, prove that the particular d square y by dx square minus m plus n dy by dx plus mn y equal to 0. Let us solve this. Here you have to check that the given function is y equal to a into e to the power of mx plus b into e to the power of nx. d square y by dx square means you have to differentiate 2 times. The given function has to be differentiated for 2 times. So for that reason, let us differentiate this 2 times. That will be dy by dx equal to a into m e to the power of mx plus b n e to the power of nx. Here you must know the formula of differentiation of e raised to ax. Clear? The formula of differentiation of e raised to ax is a into e to the power of ax. So for that reason, m into e to the power of mx, n into e to the power of nx. Now let us simplify again. That means we have to differentiate 2 times. That will be a into m square e to the power of mx plus b into n square e to the power of nx. So this type you are going to get. Clear? Y equal to differentiation a into m e to the power of mx plus b n e to the power of nx. If I differentiate again, a m square e to the power of mx plus b n square e to the power of nx. So now see here, you have differentiated 2 times. Now you have to prove that this term is equal to 0. So for that reason, consider the given equation. What is that? d square y by dx square minus of m plus n into dy by dx plus m into n y. Okay, you consider this equation. Now let us prove this equation is equal to 0. So for that reason, in the place of d square y by dx square, you write what you have got. That is d square y by dx square is a into m square e to the power of mx plus b into n square e to the power of nx. Next, in the place of minus m plus n, you write minus of m plus n into what is dy by dx. Write dy by dx. dy by dx is a m e to the power of mx plus b n e to the power of nx. Next, here in the place of m n y, you write same as it is plus m n y. What is y? a into e to the power of mx plus b into e to the power of nx. So now you have written all the terms, right? A m square e to the power of mx plus b n square e to the power of nx in the place of d square y by dx square minus the same term minus m plus n a into m e to the power of mx plus b n e to the power of nx. Next plus mn a into e to the power of mx plus b into e to the power of nx. So now simplify this, that is a into m square e to the power of mx plus b into n square e to the power of nx minus m into these two terms. What will be those terms? Minus m into this term minus a m square e to the power of mx minus m into this term minus b m n e to the power of nx minus n into this term minus a m n e to the power of mx, again minus n into b term, that is minus b n square e to the power of nx. Now this term plus a m n e to the power of mx plus b m n e to the power of nx. So you simplify all the terms and write. So now see which terms you are going to get cancelled. A m square e to the power of mx minus a m square e to the power of mx, these two will be cancelled. B n square e to the power of nx minus b, okay, minus b n square e to the power of nx, these two terms will get cancelled. Minus b m n plus b m n, these two terms will get cancelled and remaining those two terms are also will be cancelled. Therefore this is equal to 0. Clear students? Your answer will be equal to 0. That means therefore you have to write therefore d square y by dx square minus of m plus n dy by dx plus mny equal to 0. This is your answer. So here there is no place to write. So that's why after this 0, therefore you put therefore and you write your solution. Clear students? So this is one of the important question for your exam from your differentiation chapter. So that's why make sure that this is perfect. Here you take after the 0, therefore d square y by dx square minus of m plus n dy by dx plus mny equal to 0. Don't write in the middle of answer. This is the last step, that is you have to write therefore, not in the middle. Clear? So now you can write your notes from by pausing your video. Now let us go for the second problem. Okay, in the second problem, if y equal to 3 into e to the power of 2x plus 2 into e to the power of 3x, prove that d square y by dx square minus 5 dy by dx plus 6y equal to 0. That is your equation of second order which you have to prove. Clear? What is the given function? Y equal to 3 into e to the power of 2x plus 2 into e to the power of 3x. The same procedure which we have solved for the first problem, that you have to follow. So first you have to differentiate once. First you write this 3 into e to the power of 2x plus 2 into e to the power of 3x. So here you differentiate once. What you are going to get? dy by dx equal to 6 into e to the power of 2x plus 6 into e to the power of 3x. Because differentiation of e to the power of 2x will be 2 into e to the power of 2x. Differentiation of e to the power of 3x will be 3 into e to the power of 3x. So for that reason it will be 6 into e to the power of 2x, 6 into e to the power of 3x. You differentiate again, d square y by dx square equal to, this will be 12 e to the power of 2x plus 18 e to the power of 3x. Because again differentiation of e raised to 2x is 2 into e to the power of 2x. Differentiation of e raised to 3x is 3 into e to the power of 3x. So multiply, it will be 12, it will be 18. So consider your equation. Consider, what is that? D square y by dx square minus of 5 dy by dx plus of 6y. This must be equal to 0. Let us prove that. Consider this. So now d square y by dx square is what? 12 e to the power of 2x plus 18 e to the power of 3x. Next, minus 5. What is dy by dx? 6. That is 6 e to the power of 2x plus 6 e to the power of 3x. So this is dy by dx plus 6y. What is y? 3 into e to the power of 2x plus 2 into e to the power of 3x. So write all these terms. Now simplify. What you are going to get? 12 e to the power of 2x as it is, 18 e to the power of 3x as it is, minus 5 into 6 minus 30 e to the power of 2x. Again minus 5 into 6 minus 30 e to the power of 3x. 6 into 3 plus 18 e to the power of 2x. 6 into 2 plus 12 e to the power of 3x. So this is equal to 12 e to the power of 2x. 18 e to the power of 2x will be 30 e to the power of 2x. 18 e to the power of 3x, 12 e to the power of 3x will be plus 30 e to the power of 3x. Again here minus 30 e to the power of 2x minus 30 e to the power of 3x. So if I simplify this, here you can cancel these two terms. Therefore your answer will be equal to 0. Therefore d square y by dx square minus 5 into dy by dx plus 6 into y will be equal to 0. So this is your solution. Clear students? So if you write this much, this is enough for the evaluator. Clear? So that is why the given function differentiate once, differentiate twice, take the given equation. This you have to make equal to 0. Therefore write the given all terms and you simplify, add all those terms, and lastly they will get cancelled and it will be equal to 0. So this was your second problem from differentiation of second order. Clear students? Okay students, now let us go for the third question. Clear? First and two were the same. Clear? If you know the first one, you can solve the second one, but here the third one is little bit different. This is also of second order, that means you have to differentiate for 2 times, no problem, but it is different from first 2 problems. There if you know one, you can solve both 1 and 2. Here the third one is little bit different. Let us see that. That is, if y equal to tan inverse x whole square, then show that x square plus 1 whole square into d square y by dx square plus 2x into x square plus 1 dy by dx equal to 2. You have to prove. Okay students, so now let us try to simplify this. What is the given function? Y equal to tan inverse x whole square. Clear? Okay. Now you have to differentiate this. How to differentiate? What is dy by dx equal to? See, this is tan inverse x whole square. Here you have to apply chain rule because it is the composition of 2 functions. That is, one tan inverse, another one is power. That means it is in the form of f of x to the power of g of x. Here g of x is constant, that is 2. Tan inverse x is f of x, g of x is constant function, that is 2. But this is in the composition of f of x and g of x, where g of x is constant function, f of x is tan inverse x. If your function is in the form of exponential, or if your form of composition, in those type of situations, in some time you use the chain rule to simplify. Clear? Here because g of x is constant term, that's why I apply chain rule. Clear? If g of x is not constant function, there is some other rule. So for that reason, whenever g of x is not constant function, I will tell you that time what we have to do. But here g of x is constant function, we have to use chain rule. According to chain rule, first you have to differentiate the power. As you all know, what is the differentiation of x raised to n? N into x to the power of n minus 1. So for that reason, 2 into tan inverse x to the power of 2 minus 1 will be 1. So no need to write 1, here it will be 1. Clear? After differentiating the power, multiply the term with the differentiation of tan inverse x. Have you got my point? Listen carefully. You have to differentiate y equal to tan inverse x whole square. It is in the form of composition, where g of x is constant function. So that reason we have to apply the chain rule. While applying the chain rule, please make sure that you have to differentiate the power first. So it will be true tan inverse x to the power of 1 multiplied with differentiation of tan inverse x. What is differentiation of tan inverse x? 1 divided by 1 plus x square. Clear? So this will be 2 tan inverse x into 1 divided by 1 plus x square. So now what I will do, I will multiply 1 plus x square to dy by dx. What it will be? 1 plus x square into dy by dx, that is equal to 2 times of tan inverse x. I think now you got what I have solved here. So next what we have to do? See, again you have to differentiate because this is of second order. For that reason, again you have to differentiate u into v form. It is in the form of u into v. So you have to apply product rule to differentiate. So for that reason, you apply u into v rule. It will be what? 1 plus x square into d square y by dx square plus, now you have to differentiate 1 plus x square. It will be 2x into dy by dx equal to, here you differentiate tan inverse x. It will be 1 divided by 1 plus x square. Clear? Now you multiply 1 plus x square to again this term. So what it will be? 1 plus x square whole square into d square y by dx square plus 2x into 1 plus x square dy by dx equal to 2. So now you see what you need. Show that the same equation here you have got by simplifying this. Clear? So this will be 1 plus x square whole square d square y by dx square plus 2x into 1 plus x square dy by dx equal to 2. So y equal to tan inverse x whole square. You simplify 2 tan inverse x into 1 by 1 plus x square by using the chain rule. You multiply 1 plus x square to this side, u into v form. You have to differentiate u into v form. After the differentiation of u into v form, you will get this term. Again you multiply 1 plus x square to this side, you are going to get your required result. Clear? Therefore, you write that is 1 plus x square whole square d square y by dx square plus 2x into 1 plus x square dy by dx equal to 2. So this is your solution. Clear, students? So we have proved that 1 plus x square whole square d square y by dx square plus 2x into 1 plus x square dy by dx equal to 2. This was your third important problem. Okay students, now let us go for the fourth problem. That is, if y equal to 3 cos log x plus 4 sin log x show that x square y2 plus x y1 plus y equal to 0. That is nothing but x square d square y by dx square plus x dy by dx plus y equal to 0. You have to prove. y2 means d square y by dx square, y1 means dy by dx. So that you have to know. Clear? So you have to show that. For that reason, let us try to solve this. Y equal to 3 cos of log x plus 4 sin of log x. Now you have to differentiate. Clear? Now you have to differentiate. Again, composition of two functions. See, composition of two functions is different. Exponential function is different. Product of two function is different. Clear? So in the form of composition, you have to apply chain rule. In the form of product, you have to apply product rule. In the form of exponential, I will explain later. You have to apply logarithmic rule. Clear? So for that reason, let us differentiate this. That is dy by dx equal to, first, differentiation of cos. Clear? If the power was present, you used to differentiate power first. But if the power is not present, the term which is first, that you have to differentiate. Clear? So what is differentiation of cos? Minus sine. So it will be minus 3 sine of log x multiplied with what? Differentiation of log x. What is differentiation of log x? That is 1 by x. I will write it as divided by x. I will write it as divided by x. Clear? So differentiation of 3 cos log x is minus 3 sin of log x divided by x. What about this term? Plus 4 cos of log x divided by x. Same as it is. Sin differentiation is cos, log differentiation is 1 by x. So 4 cos log x divided by x. You take x and you multiply to dy by dx. It will be x into dy by dx. This is equal to minus 3 sin of log x plus 4 of cos log x. You are going to get. Again, you have to see show that. What is that? Second order. That means you have to differentiate for 2 times. So if I differentiate for 2 times, again this is product rule. Here no problem. You have to apply product rule here. It will be x into d square y by dx square plus dy by dx. Because differentiation of dy by dx is d square y by dx square plus differentiation of x is 1 into dy by dx. This will be equal to. Same here, differentiation of sin is cos. So minus 3 cos of log x, differentiation of log x is 1 by x, minus as it is. Clear? Because differentiation of sin is cos. Here differentiation of cos is minus sin. For that reason, minus y sin of log x divided by x you are going to get. So now you got all these terms. Using all these terms, let us show this. Divided by x, again multiply to LHS, it will be x square, multiply to x, it will be x square d square y by dx square plus x into dy by dx equal to minus 3 minus 4, take minus sign common, minus of 3 cos of log x plus 4 sin of log x. So my dear students, so see here 3 cos of log x plus 4 sin of log x is nothing but your y. Clear? This term is nothing but your y. So here you can write y. That will be minus y. You take to LHS, it will be plus y. So that is x square d square y by dx square plus x into dy by dx equal to minus y. Clear? Take minus y on this side. X square d square y by dx square plus x into dy by dx plus y equal to 0. Therefore, you got your required result. So that is, you must know differentiation of cos of log x, sin of log x. Differentiation of cos of log x is what? Sin of log x divided by x, because you have to apply chain rule. Here differentiation of sin of log x is cos of log x divided by x. Clear, students? So it will be again very easy problem if you remember the formulas of cos of log x and sin of log x. Differentiation of cos of log x is sin of log x divided by x. Here sin of log x is nothing but cos of log x divided by x. That divided by x you have to multiply to LHS. Again the same terms you have to differentiate 2 times. For the second differentiation, again sin differentiation is cos, log differentiation is 1 by x. So sin of log x will be cos of log x divided by x. Cos of log x will be minus sin of log x divided by x. Further, you just simplify, take minus sign common, you are getting your y term. So take minus y on this side, you are going to get your required result. So this is your 4th problem. Okay, students. Now let us go for the 5th problem. That is, if e raised to y into x plus 1 equal to 1, then prove that d square y by dx square equal to dy by dx whole square. Clear? So here this is given, you have to prove this. Clear, students? So for this, again this is a very simple problem if you know the formulas. Okay, so let us simplify this. Given e raised to y x plus 1 equal to 1. Okay, students, e raised to y I will take on LHS. It will be x plus 1 equal to e raised to minus y, because if I take e raised to y here, it will be 1 by e raised to y. So 1 by e raised to y can be written as e to the power of minus y. So for that reason, you remember that 1 by e to the power of y is nothing but e to the power of minus y. Now you differentiate this term. If you differentiate, what you are going to get? Differentiation of x plus 1 is 1. Differentiation of e raised to minus y is minus e raised to minus y into dy by dx. Have you got my point? Differentiation of e raised to minus y is minus e to the power of minus y into dy by dx. See here, if you have e raised to x, differentiation of e raised to x is e raised to x. If you have e raised to minus x is e raised to minus e to the power of minus x. Clear, students? Suppose here if you have y, you have to write it as e raised to y into dy by dx. That is what your formula says. Here if you have minus y, here you have to write minus y into dy by dx. You should remember these things. Clear, students? If you know that, these things will be very easy. This further explanation of this formula let us do later. So now you just remember those 2 things and let us simplify this. Okay, now minus can be taken on this side, it will be minus 1. Again if I take on this side, it will be minus 1 by e raised to minus y. If I simplify this, it can be written as minus e to the power of y equal to dy by dx. You write it as equation 1. Clear, students? Take e raised to y on that side, it will be e to the power of minus y. So differentiate on both sides. 1 equal to minus into e to the power of minus y dy by dx. So for that reason, if I take this term on this side, it will be again minus e to the power of y dy by dx. Now you differentiate again. What you are going to get for this minus e to the power of y into dy by dx. This is d square y by dx square, because we know that minus e to the power of y is, see here, e to the power of y dy by dx. If you have minus sign, it will be minus e to the power of y dy by dx. So for that reason, from 1, what you can write? Don't write here. Okay, let us write here. From 1, what you can write? Minus e to the power of y equal to dy by dx. In this place, you write dy by dx. This term same as it is, dy by dx. This is equal to d square y by dx square. So therefore, dy by dx whole square equal to d square y by dx square is your required solution. Clear, students? Very easy 5 problems. Clear? So these 5 problems has to be perfect. Clear, students? So for that reason, if e to the power of y x plus 1 equal to 1, prove that this particular term, you must remember these formulas. If you know these formulas, this will be very easy. First step, e to the power of y, on this side it will be e to the power of minus y. Differentiate once, this will be 1, this will be minus e to the power of minus y dy by dx. If you write this term on LHS, it will be minus e to the power of y equal to dy by dx, because I have explained what it will be if I come on RHS. By taking this, again you have to, for again taking equation 1, you differentiate again, you will get this term. From 1, you replace this term, e to the power of minus y, it will be dy by dx. So therefore, dy by dx whole square equal to d square y by dx square is your answer. Okay, students. Now let us go for the 6th problem. What is your 6th problem? If y equal to sin inverse x, then show that 1 minus x square d square y by dx square minus x into dy by dx equal to 0. So you have to show that. Clear? So no problem. Here you must know the formula of differentiation of sin inverse x. Differentiation of sin inverse x is 1 by root of 1 minus x square. Clear, students? So here the differentiation of sin inverse x is 1 by root of 1 minus x square. Clear, students? So you remember the formula of differentiation of sin inverse x, that is 1 by root of 1 minus x square. So using that, let us differentiate this. So y equal to sin inverse x, differentiating this term, dy by dx equal to 1 by root of 1 minus x square. Now multiply this to LHS, it will be root of 1 minus x square into dy by dx equal to 1. See, again u into v form equal to 1. Clear? Before solving u into v form, let us remove the root. For the solution of this root, what we have to do? We have to multiply, we have to squaring on both sides. You make squaring on both sides. Clear? By squaring on both sides, you are going to get 1 minus x square into dy by dx whole square equal to 1, because 1 square is 1. No problem. It will be 1 minus x square, it will be dy by dx whole square equal to 1. So now you differentiate again. This is u into v form. You have to differentiate u into v form. For that, let us take 1 minus x square. If I want to differentiate this by chain rule, it will be 2 into dy by dx into d square y by dx square. Clear, students? Now we have differentiated dy by dx whole square. Differentiation of dy by dx whole square is 2 into dy by dx multiplied with d square y by dx square plus, now you have to differentiate this term. What you are going to get? Plus, as it is, differentiation of this term will be minus 2x. So plus into minus will be minus 2x into dy by dx whole square equal to 0, because differentiation of 1 is 0. From this, see what are the common terms? 2 into dy by dx, 2 into dy by dx are common. So for that reason, by dividing 2 into dy by dx on both sides. By dividing 2 into dy by dx on both sides, what it will be? 1 minus x square. This will be cancelled. That is d square y by dx square. Again here 2 will be cancelled. Dy by dx will be cancelled. X into dy by dx equal to 0. So this is what your answer. Clear, students? 1 minus x square d square y by dx square minus x into dy by dx equal to 0. Here the important thing is you must know the differentiation of sin inverse x. If you know the differentiation of sin inverse x, then it is very simple. 1 divided by root of 1 minus x square. Take root of 1 minus x square on this side, make squaring, then you differentiate u into v form. After differentiating u into v form, you are going to get this. Divide the whole term by 2 dy by dx. So you will get your required result. So be perfect with this. Be perfect with this 6 particular problems. So further the important problems will be discussed in the next class. Before going to next class, make sure that these 6 problems are perfect.